We know weight impacts takeoff performance. Generally, the greater the weight, the longer the runway. But airports can't always just lengthen the runway. Usually, we add horsepower to overcome wing loading. But today, we're going to focus on the design of the plane. Modifying wing loading is a way engineers can increase payload without lengthening takeoff performance. Wing loading is the ratio of the plane's gross weight divided by the surface area of the wing. Wing loading is similar to density, except it uses surface area and not volume. This means a plane with a short wingspan, but a medium weight, is going to have the same wing load as a heavier plane with a much larger wingspan. Again, we start this investigation with a bit of mathematical modeling. We will increase wingspan while keeping mean chord and weight constant. This will increase surface area. Calculate the different wing areas by multiplying wingspan by mean chord. Then, calculate wing load by dividing gross weight by wing area. Fill out the chart under Mathematical Investigations in your student handbook, and then complete the corresponding graph. Next, we will calculate and investigate wing load when wing area stays constant and gross weight decreases. Take a moment to fill out the next chart and graph, and then to consider the set of investigative questions. Now let's move into the construction phase. To open PlaneMaker, select your X-Plane folder and Applications, and then select the PlaneMaker icon. Click Open Aircraft, select General Aviation, and double-click Vans RVs, RV10. Save the file 3 times with the following 3 names. Name WL15, name WL30, and name WL60. Where name is your first name and WL stands for wing loading. Next, you're going to want to open back up name WL30. Select Standard, click on Wings, and modify the wing of each plane according to the table under Plane Construction in your student handbook. Please note that the chord is the same for both Wing 1 and Wing 2. I am modifying our 30-foot wing length, so our semi-length for Wing 1 will be 15, and lateral arm of Wing 2 is 14.95. The vertical arm is negative 0.35. Now let's get ready to fly. Open X-Plane and click Data Collection, Settings, Data Input and Output, and if it's not already present, select the Data Set tab. Click on the last 2 checkboxes at Speeds, line 3, line 21, and line 66. Click on X to return to plane. Select each of the 3 aircrafts you constructed and take off 3 times each, trying to be as consistent as possible. Here, I'm flying the WL30. Record the takeoff distance for each flight in the tables under Test Piloting in your student handbook. Then complete the corresponding graph and investigative questions.